Now consider the exponential function fx equals 2 to the power x. Now this function is a 1 function, therefore it has inverse. So the inverse of this function, that is the function given by the expression 2 to the power x, is the function logarithm, and 2 is the base of this exponential. So the logarithm function that will be inverse of this function will have base 2. So logarithm with base 2, and then we will discuss about the input of that function in a minute. Okay. So in general, if we have 2 to the power a equals b, then what will happen is that for logarithm function with base 2, if we give it the input b, it will give us the output a. All right, or writing it more simply, what we have is that log of b with base 2 is a. So for example, say we are writing the logarithm with base 2 of 4. So we know this, that 2 square is 4. Okay, therefore what we have, we will have log of 4 with base 2 equals how much? 2. Okay, so this will become 2, and going along, say we have say we take 2 to the third power, then that's an 8. So what will that give us? That will give us log with base 2 of 8 equals how much? That will be this exponent 3. So now we have 2 to the power 0 equals, you remember this, any non-zero number to the power 0 equals 1. So what does that give us? Log with base 2 of 1 will be how much? 0. Going along in this fashion, you know this, that if I took a negative exponent, okay, say for instance I took 2 to the negative 1, that's 1/2. So log of 1/2 with base 2 would be how much? That will be negative 1. Okay, so that's how these are related, and we can go ahead and say make a graph of this function here. Okay, so here is a graph of the function log of x with base 2, and then let me put equal axes here, and then if we graph 2 to the x in the same window, okay, then notice they do look as inverses of each other. And actually let me restrict the view of the vertical side to less than that, so you can see these two functions are inverses of each other. Okay.